Hi, my name's Reagan Pearce. I'm a third year PhD student at University College London, also working with King's College London. And the title of my PhD project is Bringing Back the Burbot via Hydrological Rewilding. And the primary focus of the project is trying to see whether it's feasible to reintroduce the burbot, an extinct British fish, at least in the UK, to a river in Norfolk called the River Wissey. And that's mainly based in trying to identify whether there's suitable habitat throughout the river. Yeah, so the burbot lota lota is a type of freshwater cod. It's got the second largest distribution of any freshwater fish, and it's got a circumpolar distribution, and it's found throughout Siberia, North America, and throughout Europe. There's two distinct subspecies, actually, the North American group, as well as kind of like the Euro-Siberian group. And because it has such a large global distribution, that obviously means that there are kind of different population trends as well. So if you look on the IUCN website, it will be marked as least concern, but there hasn't actually been an updated review on burbot populations and kind of their threatened status for the last 10 years. So I think the North American subpopulation is getting on quite well, but the majority of like my focus and my research and kind of the leading concern is focused on the European groups, and also kind of the concerns extending to the Siberian subpopulations as well. So typically the burbot, it's a very distinct looking fish, slightly, I wouldn't describe it as charismatic. It's but two of the most interesting things about this fish is that it's got a very distinct chin whisker, which is a little charming. It's called a barbel, and then also it's got a beautiful green yellow mottled coloring, which is very distinct for this species. It's thought that burbot in English rivers, and it would be the same in smaller European rivers, were thought to be grow between 30 and 60 centimeters. So we're not talking very big fish. In American populations, I think they can be over 120 centimeters, which is just absolutely huge. But they're bottom dwellers. The adults prefer to stay kind of like in the deeper river habitat, but they're also described as top level predators. It doesn't mean that they'll dominate the river system that they're in. They'll happily coexist with other top level predators such as brown trout, and help to also kind of like bring balance back into the rivers, especially where they've been lost. We kind of hope that will be the case in the UK, or in English rivers, sorry, where we kind of have a long history of stocking our rivers. So with especially with kind of desired fishing and angling species, this is most commonly brown trout. You can find in a lot of rivers, if you see normally a big brown trout, it's not going to be a wild individual. It'll be a stocked individual. So we're hoping, especially in kind of our candidate reintroduction site, if the reintroduction does happen, it will help to kind of bring back balance to the fish community. They've also been described as opportunistic feeders, which essentially means they eat anything. They start when they're very small and they feed on zooplankton, and then as they grow older, they'll move to kind of eat insects in the water, and that can be like the snails, mayflies, even the small crustaceans. And as the adults get large enough, and this depends on how much they can feed on and how big their kind of mouth size gets. As soon as their mouth is big enough, they'll put anything in it. So they start eating fish as they get bigger. But it's thought actually, especially in the smaller kind of European streams, you won't really get the sizes required to eat, especially big adult fish. Maybe like when you have very young fish, they'll snack on those. But yeah, so they kind of like shift what they eat as they get older, but they're not thought to be, unless we could have like bigger individuals, they're not thought to exert that much of a pressure on kind of like the rest of the fish community. But one interesting thing is a study, and this is kind of particular with, they're thought to have like, because they're a top level predator, they're thought to have the ability to control invasive species. This needs kind of more study, but they have been found to eat different species of crayfish. And this is quite interesting, and it piques a lot of ears in the UK and in freshwater ecology, because in the UK we have a problem with the American signal crayfish, and it's kind of resulting in just demolishing our native white claw crayfish population. So there's a small hope in the back of everyone's minds that we'll bring the burbot back and they'll munch all these signal crayfish and kind of introduce a control. I think the most interesting, the thing I find the most interesting about this fish is probably one of the reasons why it went extinct, is that it's a pretty fussy fish in terms of the type of habitat required. So for each life stage needs a different type of habitat. The adults, as I previously mentioned, occupy the deeper, cooler water, as you kind of find in pools, and if you have a stream leading in a lake, which isn't so common in England, but so mainly pools, but they also have preference for kind of shelter structures. So this will include undercut banks or tree roots or woody debris, maybe boulders even. And then the juveniles have preferences for slower flowing water found in very lovely meandering rivers. And also they'll be found in the slower waters of the back channel systems, often in areas that have a lot of aquatic plants. They'll go right in there to shelter from predators. And then the adults spawn on inundated floodplains, so normally in wet woodlands or on meadows. And essentially, if you add all of this together, which we don't get that often in the UK, is laterally connected. So when you have the main river channel frequently connecting to the floodplain, but also all of these woody debris, tree roots, so trees going close to the riverbank, allowing their roots to go into the water, a lot of plants, aquatic plants in the water. This means we have laterally, physically complex river habitat. There's lots of tiny little nooks and crannies and niches for other species to come in. So it's really, really healthy river habitat that, when you link all these things together. And it is something that's been missing from European rivers more generally, but also especially in the UK, where we've had such a heavy history of kind of straightening our rivers, deepening our rivers, and building embankments on our river channel and disconnecting our rivers from the floodplain. And this type of laterally connected, physically complex habitat is not just good for the burbot, it's also good for other fish species, it's good for the insects in the water, it's good for the plants, it's good for things like otters, and it's also good for wading birds and other bird species that rely on rivers and riverine corridors.
The UK, is it more of a threatened species in the UK then because of that?
In the UK, actually, it's extinct. The last recorded catch was in 1969 near Aldreth, Cambridge. Interestingly, it's still, because it was only, I can't do that math, 50 so years ago. So there will be people alive today that remember angling for this fish when they were younger. It's still a protected species under the Wildlife and Countryside Act. So if we had this fish back, we would have to actively conserve it and the habitat it uses, which is why reintroduction is so important. Because if we could bring this fish back, at least in English rivers, you'd have to actively protect and conserve the habitats it uses, which is then really great for all these other species. But yeah, the historical distribution in the UK, it was found in eastern flowing rivers. So that's like the Norfolk and Suffolk rivers, all the way up the eastern coast of England. But it's also found in kind of like the Yorkshire Derwent and Yorkshire Ouse, and those kinds of rivers.
And so you've spoken before about it being an umbrella species.
An umbrella species is a species in which, if it's protected and conserved, would also have the effect of kind of protecting other species. So really good and probably most commonly cited example is tigers. Because they have such a large kind of like territory range, you have to protect and conserve all of that like forest. And then within that forest, you have other bird species, other mammals, other insects, other plants, other fungi that are now protected under the umbrella of the tiger. So similarly with the burbot, if we actively conserve the habitats it uses, it's going to help, it's going to cover, and under the umbrella of the burbot kind of conservation initiatives, you're also going to help out other fish species, other insects, other plants, birds, and kind of the list goes on.
So the burbot could be the reintroduction of the burbot could be responsible for so many other creatures.
Yeah, and I think it's especially important when we consider the English setting, and it's also, I think I've spoken to people who have handled the species reintroduction in Belgium, and they kind of have a similar point of view, is that freshwater ecosystems are in decline. That's in terms of kind of like their water quality and kind of like biodiversity, so that we're also observing a lot of species decline. I think over 40% of European freshwater species are considered threatened. And this is despite over 30 years of river restoration practice, which is essentially kind of the school of thought that's emerged from our long history of river modification. We've kind of recognized that we're doing damage to rivers, and river restoration is the process of trying to naturally return natural processes to rivers, often through human intervention. So a good example and a common example is if you've straightened your river out where it used to meander, well, we're going to go back in and we're going to set it back on its natural course. And the thinking is, if you kind of restore the physical habitat, then you'll then provide like the habitats for the ecology to come. Unfortunately, despite these 30 years of river restoration, we're not seeing an improvement in freshwater biodiversity. Like the physical habitats are getting better where this kind of river restoration is done, but the ecology is not improving. And we think this is because traditionally, like river restoration is focused at too small of a scale. So just the remeandering, where the rest of your whole river catchment is still straightened or embanked and or has embankments. And it's also because maybe the ecology is gone. We've lost these source populations that maybe would come into this newly remeandered river section, or it's not that they're lost, it's just that longitudinally, like as you go down the river course, there's in-stream barriers like sluices or weirs or dams, so they can't get to this nice fancy new habitat. So the ecology, it's got to be like leading in the conservation actions we do. So with the burbot and species reintroductions more generally, they're becoming more popular as conservation tools because there's kind of like that missing stone, kind of like in trying to reinforce and build our rivers back up. So it's hoping, and it's my hope with the burbot reintroduction, because you have that legal requirement to protect the habitats, because it uses so many different habitats, that it would give river restoration the push it needs to not only like increase the scope, so in looking laterally into the floodplain instead of just in the main river channel, you also have to look at the whole catchment, like, okay, we might have good burbot habitat here, but what about upstream? What about downstream? And if it's, if it's not looking good for burbot, like what are we going to do about it and what methods are we going to apply?
So kind of going to the project, your research and the projects that you're involved in the reintroduction of the burbot, does that describe where you are with it, or can you tell us a little bit about the work that you're doing? So
my project has 3 main facets. In the beginning there was a 4th and a 5th, but then you kind of realize as you get going that, okay, that's not possible, or I don't have time. So there's still so much I'd like to do, but the main focuses are to do with the physical habitat, the hydrology and the water temperature, and also a little bit about water quality. So I've completed and kind of like the physical habitat work. So we took an approach where we essentially, so my study area is about 7 kilometers long, and that was selected because it's within the historical range of the burbot. There's been a previous study in 2010 by a guy called Thomas Worthington, who did his PhD kind of a bit before mine, where it was, I think the title of his PhD loosely was the feasibility of reintroducing burbot to English rivers. So he looked at he used the IUCN's reintroduction guidelines to kind of like shape his PhD. So he addressed or tried to identify causes of decline. He identified the historical range as well. And he also like consulted things like the social feasibility as well. Like he did questionnaires with anglers, conservationists, members of the public, and how they would receive, a burbot reintroduction. It was all quite positive. So he also identified that the Wissey was probably one of the places most likely, because it's part of the Greater Ouse tributaries in Norfolk, and they were the #1 spot that contained most likely contained the most suitable habitat for burbot reintroduction. So he already zoomed in on the Wissey, and then so we've taken it the step further, and we're like, okay, we're saying this is the candidate reintroduction site, so let's get in there and assess the details. And it was also subject to something called a population viability analysis, which essentially models, okay, you've put a reintroduced population in, how is it responding to the environmental factors as they are now, and like how long will it survive for, how long is the population viable? And he identified that the main barrier was the availability of spawning habitat. So based on this previous research before we started, we were like, okay, well, we've got a study area, and we already know the causes of decline as well, I should say, as the main driver was habitat modification. So that prevention, as rivers have been straightened and deepened and embanked, that disconnection between the main river channel and the floodplain prevented the life cycle from completing between adults and spawning, which essentially resulted in this slow decline. So we knew before we started that physical habitat was a main thing. And what we did, because river habitat surveys we have currently, the most common ones, that's the River Habitat Survey, and we also have a newer one emerging over the last 5 years called the Modular River Survey, which takes a more open access approach to river surveying, because the National River Habitat Survey, you have to be specially trained, people are paid to go out and do it, or like professionals are paid to go out and do it. And the data is a bit more guarded and it's hard to understand. And it's also I think you record over 100 kind of like parameters. And this was just too much information, and kind of we thought it was really, really important to take a species specific approach. And we keep saying we've got to view this habitat through the eyes of the burbot and think about what it needs and what it responds to. So these kind of habitat preferences for tree roots and woody debris, slow flowing water, high aquatic plant cover, that was central to our survey. So we did a custom survey where we essentially walked the whole thing, and instead of just recording, I'm standing here and I can see that there's woody debris or tree roots or a lot of plants, we actually mapped it. So it was beautiful. We did it in August and September 2021, and I just spent my days 7 hours, 8 hours at a time just sketching, which hand hurt by the end of it, but it was beautiful weather, lovely exercise. But what we were able to do is mapping that and also taking spot measurements every 10 meters to kind of record like these burbot relevant features, and then also kind of like indicators for, so what we took an estimate for depth, which is an indicator of adult habitat, and then we took an estimate for these 10-meter units, what is kind of like the aquatic plant percentage coverage. So we'd estimate that in that 10 meters, about 70% is covered by aquatic plants. And we'd also record things, there's something called a flow type, which just describes how the water moves. So, and that's just categorical as well. So we describe, if we said, this 10 meter is dominated by a glide, then we know it's very slow moving water, which is very important because this fish has such a slow swimming endurance. And when you think of all these things, you're like, okay, no wonder you went extinct in the UK. And then we also recorded dominant substrate type. So then what that allowed me to do is look at every 10-meter unit across the 7-kilometer study area. And with all this information, I could classify it as, is this suitable for adult? So what is the depth? Are there shelter preferences here, like tree roots, woody debris, etc.? Is it suitable for juveniles? Is there slow flowing water here? Is it a glide flow type? Is there slack water, which is just kind of very, very still water? Does it also have high aquatic plant coverage? Or is it suitable for spawning? Because even though their main strategy is spawning on inundated floodplains, they have been known, and I think that's how they've kind of survived throughout Europe. They will spawn in stream if they need to on small gravel patches. So there was a small facet of the in-stream habitat work that did consider this. Or is it just unsuitable for any life stage? And so for each 10-meter unit, they all got a classification. And then we found overall, at the end, essentially what we found is that there is habitat for each life stage, but there's issues now to do with the connectivity between these patches. So I think the in-stream spawning habitat, which you'd expect because it's not their main spawning strategy, has maybe the lowest proportion throughout the study area. But it's also very scattered. So we're kind of thinking, okay, well, these are only 10-meter units. You're not going to get a whole population spawning on just one 10-meter stretch. So it's very important to consider the connectivity in the location. And we actually found the largest category was unsuitable, actually. But it left us asking questions of, initially that's quite worrying. You're hoping it would be more adult suitable or something, but the questions that left us wondering was, okay, this might be unsuitable, but how unsuitable is it? Like, is this large compared to other rivers? Is this quite a small proportion? Because the River Wissey, especially the area we're looking at, is, my supervisors who have had long careers in kind of like river and ecology absolutely love being there because it's a very beautiful river. So to them, they're not so deterred by the 40%, but it's quite hard to then, fully say, is this good or is this bad? But and we still are, we strongly recommend that Norfolk Rivers Trust, who is kind of leading the reintroduction, really get into this area and try and reduce it just to give the species the best possible chance it can. So that was the main facet. And then we've also looked, which is a bit simpler to describe, is we've done a desk-based study where we use aerial imagery to just kind of classify different river habitats. So that would be like areas of similar elevation, or if we see a back channel going up, and we classify that and then calculate the area to be like, okay, here is available spawning habitat, and how much of the floodplain would be available to spawn as spawning habitat. And it looks really good for the Wissey. And to help also avoid that kind of like, oh, but how good is it? We also repeated it in Belgium with the original reintroduction river, a section of the original reintroduction river, because it's very long, we didn't do the whole thing, called the Grodenida, which is, in the early 2000s, they undertook their own burbot reintroduction because they also lost their burbot. So they reintroduced it there, and now it's spread to other rivers, and I think it was in 2018. So it's quite an investment. From the 2000s to 2018 was when they first recorded natural recruitment. So they stopped putting in juveniles, and they had to just go hands off and just say, is it going to happen? And it was quite a few years where they had nothing. And then suddenly 2018 and every year since, they've recorded like juveniles and spawning adults in kind of the spawning habitat. So it was really important for us to kind of compare to a success story, and maybe also not a population that's persisted, but is more like in decline. We know maybe, okay, this habitat in Belgium, it's like it can still be improved. All habitat can get better. But it was important to have that they can survive here, and they are reproducing, even if it's like, just very slow recovery. So we compared to that, and then also to another site in which they have spread to themselves within their Belgian historical range. But then this other area called Beersils Geobrecht, sorry, my Dutch accent is not that good. They actively manage it as a wetland, like they've tried to restore it to encourage connectivity between the main channels and the floodplains, and they actively manage it for kind of burbot spawning as well. So this was kind of meant to be like, okay, well, if this is going to be our very good site, and if the Wissey can kind of compare to this, it's really good. And we found, our results of our early results show that it is quite good. It's somewhere between the Grodenida and this kind of, wetland site, which is what you'd expect, because the Wissey isn't managed as a wetland. It does flood in areas because at the lower end there's a lot of wet woodland, but there's still parts of it that you can see like legacies of modification. There's areas that still have embankments that prevent flooding, even though you can see the river wants to flood. But it's overall, the results from that habitat work are encouraging and are positive, but probably the emphasis is it could be better. And that's so important, because the main reasons fish reintroductions and more generally species reintroductions, so any animal, bird, whatever, fail is because one, you don't fully understand or gauge with the species requirements in terms of their biology and ecology, but also you misunderstand like the release habitat, like either it's not quite the right quality or it doesn't have all the requirements needed. So it was so important for us to like get this right. And so it's also further important for the Norfolk Rivers Trust to keep improving it, to try and get it as good as possible. Just to give the reintroduction the best chance possible of survival. And then so the two other avenues of my project that I'm going into, which are much shorter because I'm still working on them. One is related to the hydrology. So to do with how often does this river flood? So it again relates to the spawning habitat, which has been identified as the most crucial thing and most likely to prevent a long-term viable population. So how understanding like the kind of hydrological regime of the river. So how often does it flood? How far does it flood? How deep is it? And how long does the water stay for? So I've got a sensor network out that's monitoring water levels on the floodplain and the main river. And yeah, I'm just trying to understand the pattern, and I'm doing a little bit of hydrological modeling just to understand like what flows do you need to kind of ensure that the the river connects to the floodplain and provides that spawning habitat every year. And then the final question is to do with water temperature, and that it has two basic avenues because burbot are winter spawners. And they spawn between, well, there's a large range generally in the literature because you have a lot of literature from different areas, North America, Siberia, and they all say slightly different things because they're all slightly different genetic subgroups. But the general consensus is that they'll spawn between November and March, which is very long. But in Western Europe, you're looking at a 2-week spawning period at the end of December, early January, and you need temperatures at less than 6 degrees. And there's a really kind of strong question because the UK is just kind of coming down to like the southern part of their range, where it's like, especially under climate change, you have to consider, well, one, do our rivers even get below 6 degrees anymore because winters are just warmer than they were? And you have to think of the longevity. Is it fair to reintroduce the fish to this kind of environment if rivers are warming? And so with that, I've got temperature sensors all over, checking the floodplains and checking the main river channel because, and I feel not lucky because you don't want to see it, but the heat wave last year, I had all my temperature sensors in and I've been able to, which I'm actually going to retrieve them this June. But they captured the heat wave, and I've got one sensor that showed actually water temperature did reach, it touched on the hottest day of the year, 30 degrees. And for fish, for the burbot, again, it's debated, different information from everywhere, but they don't really like maximum temperatures of like over 27 degrees. Like it's got to be lower than that. And that's like very short term, like not more than maybe, I can't remember whether it's 24 or 72 hours, which is like the short-term critical threshold, but it cannot be long-term, otherwise you have very detrimental effects. So also considering our trajectory under climate change, or our different kind of trajectories under climate change, depending on emission scenarios, if heat waves do become more frequent, is it fair to reintroduce this fish where you could put these populations in and invest this time, this money, these resources to have them killed by these kind of heat waves that are predicted to get more frequent. So they're kind of like the avenues to explore. So it's slightly a bit beyond, the habitat is the main concern because that's, something that, without that, it can't be done unless you put in a lot of work of just kind of like reshaping the river. But then the hydrology and the temperature, there are, well, climate change you can't really control, but there are slight things to be done. And especially with the kind of how many sensors I've got in, and I'm trying to see whether there's differences between, the back channel systems versus the main channel, and the role of kind of like trees and their shading, and whether there'll be a difference in the summer. So it'll be really interesting to get kind of like the data early next month to kind of see during that heat wave, were there any differences in kind of how temperature is? Because if you have refuge for fish, then hopefully they would be able to survive even under climate change. So that's the main directions of the project. But yeah, other than that, and again, also that I'm definitely speaking from like a English burbot perspective with a little bit of Western Europe, but it's also, it does vary across different places. Like the conservation actions taking place are different. Like Belgium has undertaken a reintroduction, and there have also been some local translocations in places like France, and I think also Germany. They're also, I know in the River Lippe in Germany, they have like restored their kind of river through river widening and that's helped burbot populations as well. So there are actions being taken, but then there's some other countries where such as Denmark, I know that it's kind of like a really understudied fish. It's just kind of always been there, but it's not really kind of like a key angling fish, and hasn't really kind of got like a cultural impact. So it's kind of like been forgotten, which is also a bit sad. but hopefully maybe through this we can like spread a bit more awareness about the burbot, and that, you know, it's a pretty cool fish, it's just doing its thing. And like, it's my hope as well, kind of how Belgium view it, that especially in England, I hope it can be like a blue ambassador for kind of holistic, like interconnected, like river restoration. That, yeah, it can, yeah, river rewilding, that we can kind of take these approaches, and hopefully approaches that are more rewilding, so using natural processes, things like to, you know, removing the flood banks maybe, but then doing things like replicating natural tree fall to kind of then improve the connection between the river and the floodplain. Because if you fell a tree in, trees are just amazing ecosystem engineers. I'll just give a quick shout out to trees, because they're every part of them, like trees on, especially trees near rivers, obviously rivers are the best. Trees near riverbanks, their roots provide a structure for fish, as we've talked about a little bit, but then they also kind of stabilize banks, they provide riparian shading. Then as they get older and they die, they fall into rivers, and then they just start making absolute magic. So they accumulate sediment behind them, but then on the other side, because the water's pouring over, they also scour, so you'll create like pools and patches which fish will inhabit. But in these sediment patches, like things like seeds and stuff get caught, so then you have aquatic plants springing out, and just all of these different kind of mosaics are going on that are just absolutely beautiful. So yeah, like I think kind of trees, and there's kind of like a magic unity, I think, between burbot and beaver and trees, that really create like these beautiful messy habitats that we kind of need in rivers, because especially yeah, in England, and I'm pretty sure it's the same in Europe as well, we have had a tendency, and in conservation, to be hands-on and keep things clean and looking nice and tidy. So we used to take like all the trees and woody debris out of our rivers, and now all the research shows if you want healthier rivers, you've got to get the woody debris back in there, you've got to get your trees in. So instead of us trying to add in maybe, you know, these kind of sculpturesque kind of woody debris piles sometimes, which just can't replicate kind of nature, then, you know, where there's some old trees that could be felled, where the assessments are done right, just chop it in and let nature do the rest. And that's why beavers are so good, and they're brilliant ecosystem engineers, because they just say, right, I want that tree, and it's going in the river, and you create these pools, and they have such a beneficial effect on kind of aquatic plants and fish and insects, and also the wider riparian vegetation. It's beautiful. So definitely hydrological rewilding, thinking forward, is just so important.